All right, algebra students. So now we are on lesson 5.4. And what we've done so far in chapter 5 is we've already covered all the different ways that we can solve a system. So we got graphing, we have the substitution method, and then we had the elimination method we used yesterday. So we've covered all the different ways to solve them. So now what we're going to be looking at is some different types of systems that there are. And we're going to put those systems into some different groups and some categories. All right, so first we're going to solve some special systems of linear equations. So these are going to be the ones that just kind of seem a little bit strange compared to the ones that we have been working. All right, and then we're going to take all those different types and we're going to classify them. Okay, so we're going to basically just put them into some different types of groups. All right, so let's take a look at what we have first. Okay, the first one we're going to take a look at is when two lines in a system do not intersect. Okay, so that means we have parallel lines. All right, so that means that these lines are never going to cross, so there is no solution when we have parallel lines. We call that an inconsistent system. All right, that's what happens when we have parallel lines. Okay, so we'll take a look at an example of this. So we want to show that this system here has no solution. There's two ways that we could show it. We could show it by the graph, which we'll talk about in a few minutes, or we can show it by using algebra. All right, so what we want to do is we want to work some algebra on this system here so that we can show that it is not going to have a solution. Okay, so we want to make sure that both of our equations are in slope-intercept form like this, y equals mx plus b. The top one already is y equals x minus 4, so we just want to get the bottom one to also look like slope-intercept form. So to do that for this bottom one, I just got to move this minus x, cancel it out, go plus x, add x to the other side, and that would come out to, if I write both of them down, my top one, y equals x minus 4, and now my bottom one, by moving the x, is y equals x plus 3. Okay, so taking a look at these using algebra, both of these equations have the same slope. They both have 1x. You could put a 1 there if you want, and they have different y-intercepts. All right, if you remember anything from chapter 4, if you have two lines that have the same slope and different y-intercepts, these are parallel lines. Okay, so those two lines are never going to cross, so they are never going to have a solution to them. We can also show those two lines by graphing. All right, there's our two lines. They have the same slope, up 1 over 1, up 1 over 1, so these lines would never cross. All right. Okay, another type of special system that we can have is if both linear equations in the system end up being the same exact line. Okay, so if they are both the same exact line, they are going to have infinite solutions, okay, because they're always going to be sharing the exact same point on the line. All right, so if we have a system where we have one solution or more than one solution, we call that a consistent system. Okay, so let's take a look at what a system would look like if it is sharing the same exact line. Okay, so here is our system. We want to show that this has infinitely many solutions. We can do that using algebra, or we can graph it. For using algebra, we want to get them into slope-intercept form. All right, my top equation is already in slope-intercept form, so I'm just going to work out, I got the algebra already worked out for the second one, so if we worked out all the steps like we've done already before, then that would come out to y equals 3x plus 2. Okay, so both of them came out to the same exact equation, so they're going to be the same exact line. If we graph it, it's the same exact line, so they are always sharing any of these points. So there is infinitely many solutions. All right? Okay, so under the category of consistent systems, so if we have one solution or many solutions, we got two different groups under that category. We could have an independent solution, all right, and this is one that has exactly one solution. All right, these are the ones that we've been working with so far when we have two lines that intersect. Okay, so just to draw ourselves a quick coordinate grid here. All right, these are the ones that we've been working with all through chapter 5. So if you have one line here and another line, and those two lines cross, okay, that is a consistent system, and we would, under consistent, it would also be labeled an independent system. It is consistent and independent. The other type of consistent system we have is one that is dependent, and this is where our system turns out to be the same exact lines. So if we sketch ourselves a coordinate grid, and both of our equations come out to the same line, then it is going to be called a dependent system. It has infinitely many solutions to it. All right, and if it's the same line, we call those coincident lines. All right. Okay, so here's a chart that kind of shows, that kind of lays out the different types of groups of systems that we have. So we really just have, we have two categories. We have consistent, and inconsistent. So you can have, they can fall under the consistent category or inconsistent. All right, inconsistent means that you have parallel lines. All right, they're never going to cross. Okay, consistent systems have solutions to them. So under consistent, you could have the independent group. This is where it has exactly one solution. This is where your lines are going to cross in one spot. Okay, and you can name your X and Y coordinate where those lines would cross at. All right, like we've been doing. Okay, the other one, if you have you can have a consistent system that is the dependent group. This is one that has infinitely many solutions. They have, and they are the same line. All right, coincident lines are just the same line, one line only. All right, so there's like our three different groupings that we have: one solution, same line, or parallel lines. All right, so now what we're going to do is we're going to take a look at some systems, and we are going to get them into slope-intercept form so that we can classify them, figure out what category they belong to, and then be able to tell how many solutions they have or if they have no solutions. All right, so with these first two equations, we're going to get them into slope-intercept form. So I'm going to work with this first one. I got to get y by itself, so I simply got to divide by 3, divide by 3. All right, this is the same as an imaginary 1 right there. So this one would come out to y equals 1 over 3x, okay, that's that part, plus 1, 3 divided by 3. All right, there's my first one in slope-intercept form. Now I'm going to take a look at my second one. I just got to move my negative 1/3 x over to the other side, and I will have y by itself. So plus 1/3 x plus 1/3 x on this side, and I get y equals positive 1/3 x plus 1. All right, so what happened when we put them into slope-intercept form is that these came out to be both the same exact line. All right, and if we take a look at that chart we just looked at before, if we have the same exact line, same slope, same y-intercept, it's going to be consistent, and it's going to be in the dependent group. Okay, so that's what we would write down. All right, this system is consistent and dependent, and it also has infinitely many solutions because it is the same exact line. All right, so we're just categorizing these different types of systems into what they are. Okay, so here's another one. We'll take a look at this one here. We want to get both of them into slope-intercept form, so I'm going to work with the first one, the top one. So I need to move x to the other side, minus x minus x. So the top one's going to look like y equals negative x plus 5. Okay, so there's the first one in slope-intercept form. Second one, to get y by itself, I need to move this positive 4 to the other side. Okay, so that's going to get me y equals negative x minus 4. Okay, so here is what we got with this one. Putting them into both slope-intercept form, we can put our imaginary 1 there. That kind of helps out. So both of these have the same slope, but they have different y-intercepts. All right, if you got the same slope in different y-intercepts, that makes those lines parallel. Okay, if you wanted to, we could flip back and we could take a look at the chart just to see what we got. So here's what we just talked about. Same slope, different y-intercepts. That gives us parallel lines. That's going to make it inconsistent. Okay, so that's what we would call this thing. We would say the system's inconsistent, and we have 0 solutions. These lines will never cross. All right, so we'll take a look at this last one here. Getting these into slope-intercept form. This one's already kind of in slope-intercept form. We just got to simplify it out a little bit. So we're just going to distribute our 4. So we get y equals 4x plus 4. All right, so there's the top one. This one, we're just going to move the minus 3 to the other side, cancel it out, plus 3 plus 3. And this one becomes y equals x plus 3. Okay, so what we came up with is we have different slopes. We got a 4x and we have a 1x, different y-intercepts. If we have different slopes and different y-intercepts, all right, these lines are definitely going to cross. And when they cross, we can name the coordinate for that spot. So we would call this one consistent and independent because they cross at exactly one location. All right, we would have one coordinate where they cross. And so that just gives us one solution. Okay, so that's part of what you guys are up to today, categorizing some different systems. Now let's kind of put that into a word problem. We'll see what we got. So here we have Jared and David both started a savings account in January. If the pattern of savings continues, then we want to know, will the amount in Jared's account ever equal the amount in David's account? Okay, so it gives us the numbers here. Here's Jared, here's David. They both started their account in January. They started with different amounts, and we want to know, will Jared ever catch up to David? Will he ever have the same amount as David? Okay, so we want to write a system of linear equations. We're going to write one for Jared and one for David. Y is going to represent the savings total, and X is going to represent the number of months. Okay, so both of these guys, it's going to look like Y equals. Okay, so the total amount in their accounts is going to equal what we put over here. All right, looking at the pattern, Jared started with 25, and every month he's going up by plus 5. All right, $5 is added to the account every month. David, he started at 40, and same with him. $5 is getting added to his account every single month. Okay, so here's how we're going to write it. X represents the number of months. So for Jared, he's getting $5 every month, so it's $5 times X, however number of months went by, and then we add to that what he started with, $25. Okay, so this would represent how much money Jared has in his account. All right, David, he started with 40, so we would put that over here at the end. All right, and he is also getting $5 every month, so it would be $5 times the number of months. Okay, so there is our two linear equations for this word problem. They both have the same slope and different y-intercepts. So if we flip the screen and kind of take a look at that, same slopes, different y-intercepts, that means we have parallel lines. So there is no solution, which means that Jared, unfortunately, will never catch up to the amount of money David has in his account. All right? Check out one on your own, see what you guys can come up with. Take a look at this situation. Write one equation for Matt, one equation for Ben, and see if you can answer that question in that word problem. Pause the video, take a few minutes to work this out, and we'll see what you get. Okay, so here's what we got for these two. We got our system set up. We got our equation for Matt, and we have our equation for Ben. All right, so this one over here represents Matt, and this one down here represents Ben. We got them in the slope-intercept form. Notice how we have different slopes and different y-intercepts. Okay, so that means there's going to be one solution. So that means we would be able to actually answer this question. All right. Now to answer the question, we got to use the substitution method. We know y equals 20x plus 100, so we can take that and substitute it in for y in the bottom equation. So this is what it would look like. So if you went through all your algebra steps after that, then we have x comes out to 2 months, and if we remember back from the equation, x equals the number of months. So after 2 months, they would have the same balance in their account. All right, there's your lesson 5.4. I hope that worked out for you guys. You guys got an assignment for you for this one. It'll be up there on the board for you guys, and I will see you. Well, actually, you guys got a quiz coming up, so you got to review the next class day. Quiz after that from 5.1 to 5.4. Then I'll be back and we'll be working out 5.5. All right. I'll see you guys in a few days.